Okay, so in this video we're going to have a look at negative quadratics. We're going to have a look at factorising them, solving them, and we're also going to have a look at finding the minimum point or the turning point of one of these quadratics. Now I use the word minimum point there because normally when we're looking at quadratics we are finding that minimum point, but with a negative quadratic we'll actually call it the maximum point. We're going to have a look at why we do that and why it would be called the maximum point as we go through, but for the purpose of this, make sure you grab a piece of paper, grab a pen, make some notes, and we're going to kick start with this question. Now when it comes to a positive quadratic, or a quadratic where the coefficient of x squared is a positive number, the quadratic itself has a U shape. Okay. Now when it comes to a negative quadratic, it's the other way around. So if we were to draw them on top of each other, which I won't, in fact I'll get rid of this one, and we'll draw it the other way around, it has this shape. Okay, so a negative quadratic has this sort of shape, and we're going to be sketching them as we go through, but just bear that in mind obviously when we're looking at a negative quadratic. Now when it comes to actually solving one, we treat it in a very similar way as we do to a positive quadratic, in the sense here that we're just going to take this quadratic here, we're going to have a look at the two numbers that multiply to make that number at the end, and we're going to have a look at the numbers that add together to make the one in the middle. But obviously we have the negative x squared there, so we're going to have to be a little bit careful. Now there's a little trick for doing this. Now what we can actually do is we can take out a factor of -1. Now as it goes with this particular one, we could write that obviously in a bracket. We could take -1 out and then write what we've got left in the bracket. And in the bracket there we have -8, we would have -2x, and then we would have plus x squared, or positive x squared. Okay, so a nice easy step to start with. You can actually forget about that -1 on the outside for the moment. In terms of our working out, if we want to keep it mathematically sound here, we do need to put the -1 on the outside, but personally I just like to rearrange it so that we have positive x squared, and I'll just change all the symbols. So we've got positive x squared, the positive 2x goes to a negative 2x, and the positive 8 goes to a negative 8. And what we're going to do is we are just going to solve it from there. Technically, by doing this, if we were to imagine a quadratic graph, and if I just draw a basic one, let's just draw a little basic one here so it looks something like that. By doing this process, by timesing it by -1, or by taking that factor of -1 out, technically what we've done to the graph is we've flipped it upside down, or we've done a reflection in the x-axis. And as you can see, when we're solving it, that means that we're still going to have the exact same solutions here, whether we look at the negative quadratic or whether we look at the positive quadratic. But there is a little bit of a process we need to do in terms of making sure we factorise it properly, but in terms of getting the actual solutions, we can just imagine that it's the other way around. So let's have a look at this one then. So if we factorise this one, which is our process for solving it, remember we are solving it here, so it should still be equal to 0. But if we go about factorising it, we have to look at the factors for 8, so we have 1 and 8, or we have 2 and 4, and for this particular one, to get -2 in the middle, it's going to be +2 and take away 4. So x plus 2 and x minus 4, and that is all equal to 0. Now there we go. We can actually get our solutions from here, but we should bear in mind that this was a negative quadratic, and actually we do need to make sure we account for that when we're factorising it, just to make sure it's mathematically sound. Although we can get our two solutions from our brackets there, and which we'll have a look at in a sec, what we need to do for this negative quadratic to take into account the fact that it had the negative x squared, we just swap the number and the letter around in the bracket, but keeping the symbols the same. Now for the x plus 2, that's not going to make any difference. X plus 2 or 2 plus x, it doesn't matter how we write that. But the x minus 4, that is going to make a big difference, because if we swap them round, we get 4 minus x. So obviously we can keep it. You can write it as 2 plus x if you want. It doesn't really matter, but we don't need to swap that one round. But there we go, that's our quadratic factorised, or our negative quadratic there. We've factorised that completely. We can now get our two solutions from it. So obviously, just like with normal solving quadratics, we can set both brackets equal to 0. But as you're going to see with this one, for the first one, we get x equals -2. And for the second one there, we get x equals +4. And we could actually go ahead and draw our quadratic a little bit more accurately than now by labelling those on the diagram. But there we go, there are our two solutions. X is -2 and x is +4. But for the purpose of this, obviously there's a few topics in here that I am assuming you have a good knowledge of already. One of those being factorising a quadratic, as that's the main process we're doing here, and the other is obviously solving a quadratic by factorising. So I will link those two videos in the description, so do check those out. But we're also going to have a look at sketching quadratics as well now, so I am going to link that one in there for you as well. But let's have a look. We're going to actually go about sketching this. It's not really too much of an extra step, but it's important to be able to sketch these as well as just being able to solve them. Right, let's have a look at another one. Okay, so for this question here, it says sketch the graph of y equals 12 minus x squared, showing any points of intersection with the coordinate axes. Now there's one point of intersection we can get straight away, and that's that number at the end. Well, in this case it's at the start, but normally it's at the end when we have a positive quadratic. So that number 12 there, that's our y-intercept. So if we label that straight away, obviously we're not going to forget then, and then we can label that as later on when we actually draw this. Not forgetting as well, it's a negative quadratic, so it is going to be sloping this way, even though we are going to change it to a positive quadratic for the purpose of solving it. So when we go about solving it now, let's have a look. Now again, I am doing a little bit of, I don't want to say a trick, but I am just going to, when I factorise this -1 out, I'm not actually going to write that factor of -1. As I'm going about this in order to solve it, I don't really need to write that. But if I take that -1 out, we get positive x squared. The negative x there is going to turn into a positive x, and the positive 12 is going to turn into a negative 12. And I'm going to factorise it from there. So again, using that same process as before, we can have 1 and 12, we could have 2 and 6, or we could have 3 and 4. And we're trying to make positive 1 in the middle, so that's going to be 3 and 4. So we're going to have positive 4, take away 3, and that would give us positive 1 in the middle. Not forgetting that when it is just an x on its own, that is 1x. So in our brackets here, we've got x plus 4, and we've got x minus 3. There we go. And as we're solving it, let's set it equal to 0. There we go. Now obviously, as I said before, we do need to swap these numbers around. Now the first one doesn't matter, so we can keep that as x plus 4, but we should really swap these other ones around. So when it's factorised, it would be 3 minus x rather than x minus 3. There we go. But we can still get our two solutions from the starting brackets, remembering that you can just set the bracket equal to 0. So when this first bracket equals 0, x equals minus 4. And when this second bracket equals 0, you would get 3 minus x equals 0. Add the x over, and you get x equals 3, just as we would from that first bracket there, just flipping that minus 3 sign over. So we get x equals 3. Okay, so let's get rid of that. We need to actually go about drawing this now. So if I draw just a basic sketch, as it does only say to sketch it, we just need to take into account for the fact that the two solutions, one of them is negative and one of them is positive, and then obviously we have that y-intercept at 12. So I'm going to need to draw the positive and the negative part of the x-axis. We're going to want to go through minus 4 and 3. Don't have to worry too much about the scale here. Obviously 12 would be a lot higher if we had you know, the same scale on either one. But I need my negative quadratic to go up through the y-axis, back down. I just need to label all those points where it intersects the axes. So it goes through here on the y-axis at 12. It comes through minus 4 on the x-axis, and it goes through 3 on the positive part there. So there we go, that's how we would sketch a negative quadratic. Obviously it does say any points of intersection with the coordinate axes, so that includes the x and the y axes, so that's why we've got the y-intercept on there. And obviously that process to find where it crosses over the x-axis is to solve it. So just remember, change all the signs, factorise it, and then swap the pieces over in the bracket. Although if there is a plus sign in there like this x plus 4 one, then it's just going to remain unchanged, but you could write 4 plus x if you want. So there we go, that's how you factorise and solve and sketch a negative quadratic, and here's a couple of questions for you to have a go at. Okay, so two questions for you to have a go at. Both are asking you to do the sketch, so you need to get the y-intercept and the two solutions for both. So pause the video there, have a go, and we'll go over the answer in a sec. Okay, so for the first one then, if we take that factor of minus 1 out, we get x squared plus 3x minus 10. And if we factorise that, we'll set it equal to 0. So when we factorise it, it'll be x plus 5 and x minus 2. That'll give us plus 3 in the middle and negative 10 at the end. There we go. We don't need to swap over the x plus 5, so we'll just swap the other one over. So we have x plus 5 and 2 minus x. That's correctly factorised now. And then we can draw our sketch. So our y-intercept is 10. From the original part of the question, and our coordinates or our solutions we can obviously get from our brackets there. So we've got x equals negative 5 for the first one and x equals positive 2 for that second one. So drawing a little basic sketch, we've got 10, it's going through minus 5 and it's going through 2. and let's just label those on. So we'll label 10 on the y-intercept, and then these ones here, -5 and 2, and again not worrying too much about it being perfectly scaled when it is just a sketch. On to the second one, we've got a y-intercept of 20, and let's go about flipping these signs. So we've got positive x squared minus 1x minus 20, so equal to 0, and let's solve it from there. So it's going to be 4 and 5, so we've got x plus 4 and x minus 5 in order to get the minus 1 in the middle. And then let's just swap round that one bracket just to make sure we've correctly factorised the original equation there. So x plus 4 and 5 minus x. There we go. We get our two solutions from that. So we've got x is -4 and x equals 5. And then again we can draw our sketch. I'm going to draw a bit of a smaller one here. So -4 and 5. There we go. And let's just label those on. The y-intercept was 20. And then we've got -4 and 5. So there we go, that's how you factorise, solve and sketch a negative quadratic. Now we're going to have a look at finding the turning point. And as you can see, I already mentioned at the start that we won't be looking for a minimum point this time because the curve is upside down, or having that slope the way it does. The actual turning point is going to be at the very top of the curve, and we'll have a look at that one now, but we're going to have a look at how to actually complete the square and find that turning point. Okay, so let's have a look at that. Okay, so here's our question. By completing the square, state the coordinates of the turning point for the graph of, and then we have y equals 10 minus 4x minus x squared. Now we already know that it's sloping this way, and that turning point, that point right at the top of the curve there, is what we're trying to find. Now, with the process for this is pretty much the same as obviously looking at completing the square normally. So obviously I will link the video in the description for completing the square, so make sure you've checked that one out first because this is going to be a little bit harder than that one, but the process is pretty much the same. Now what we need to do to start with, and this time it does matter, but we're going to take that factor of -1 out, okay, and it is very important that we do actually take that factor out and show that in this one. So this is the expression we're looking at, 10 minus 4x minus x squared. And if we take that factor of -1 out inside the brackets, and again I'm going to reorder them, I'm going to put the x squared first, we'll get x squared, that'd be plus 4x, and it'll be minus 10. Now from there, what I'm going to do is I'm going to kind of ignore the fact that that -1's there, and I'm just going to complete the square for what's inside the bracket like we would normally. So again, when completing the square, we're going to halve the coefficient of x, so it would be x plus 2 in brackets squared. When we expand that, we get 4 at the end, and we want to get back to -10. Remember, -10 is in our original one. So to get from 4 to -10, it'd be -14. So that's that part in the bracket in completed square form. If we expand that out, it would match the one above. But this is where we have to remember that there was a -1 there. Now what we have to do is we have to multiply that -1 back into our expression. And I'm going to introduce a second set of brackets, because obviously we already have one set of brackets there. I'm going to put the -1 back on the outside. Now when we multiply that back in, it's easy enough. We have to multiply this bracket by -1. We don't actually have to do that. You can just stick the -1 at the start of the bracket. So -1 lot of this x plus 2 squared. And then when we multiply the -14 at the end by the -1, that's easy enough. That just swaps the sign. So that'll be plus 14. So that's that there in completed square form, and just like normal, we get our coordinates from this. So the x coordinate of the turning point is the opposite of the plus 2, and obviously I am going a little bit quicker than I would on the normal completing the square video, so do check that one out first if this is a bit beyond you. So -2, and let's put it up by a diagram, -2 would be the x coordinate, and the y coordinate is just that number at the end, which is positive 14. So it's -2, 14, and that right there is the coordinate of our turning point or maximum point for this particular graph. So there we go, that's what we're going to find. Obviously our final answer for this, the turning point, is -2, 14, and following on from this we could actually draw even a more accurate sketch now of one of these quadratics, because we can factorise and solve it to find the solutions, and we can complete the square in order to find that turning point. But there we go, that's how we're going to approach that. Let's have a look at another question. Okay, so a little bit more in depth here. Look, we've got sketch the graph of y equals 16 plus 6x minus x squared, showing the coordinates of the turning point and any points of intersection with the coordinate axes. So this is going to involve completing the square just like we've done, which we're going to start with, but it's also going to involve factorising and solving in order to find those solutions. So we've got everything accumulating together in this question. So let's have a look. Now we've got this. Now as we're focusing on completing the square for this part, we may as well start with that and find that turning point. So let's take out that factor of -1. It's going to be nice and easy for us to factorise it once we've done that as well. But if we take out the -1, we'll have positive x squared minus 6x minus the 16. There we go. And now we can complete the square for what's inside the brackets. So again, halving this coefficient of x, so that'll be x minus 3. And that's in brackets squared. That would make positive 9 when we expand it, and we want negative 16. So getting from positive 9 back to negative 16. So just obviously be careful when you're doing this, have a little think about that. So to get back to that, we're going to have to take away 25, 16 and the extra 9. And there it is in completed square form. Now obviously bringing that -1 back in, need to make sure we don't forget about that. And easy enough, we just times that back in. So -1 lot of the bracket, x minus 3 squared, and then the negative 25 will turn to positive 25. And again, from there, we can read the coordinates of our turning point, not forgetting that the number in the bracket is going to change signs. So we are going to have positive 3 and then positive 25 as our turning point. So let's highlight that. That's one of our key little bits that we're going to add on to our sketch. Now we can go about finding the solutions. Obviously, the one thing we don't need to worry about finding is that y-intercept, which was in the question originally. So let's just write that on, make sure we don't forget about that. And there we go, the y-intercept is just there, already given to us. So let's go about actually factorising it. And we can take that from here to factorise it. So our factors of 16, we can have 1 and 16, we could have 2 and 8, or we could have 4 and 4. We're trying to make negative 6 in the middle, so 2 and 8 is going to work perfect. We're trying to make negative 6, so that's going to be x plus 2 and x minus 8. That gives us that negative 6 in the middle. And obviously that second bracket there, we just need to flip the pieces around just to make sure that we keep our factorising mathematically sound here, as we are factorising the original negative quadratic. So x plus 2 and 8 minus x, and we have actually set all this equals to 0, so let's keep it there as we are solving it. So we can get our two solutions from that. So we get x equals negative 2 for that first bracket and x equals positive 8 for that second bracket. And remember, you can always read it from this one here, you don't have to read it from the one below. So there we go, there's our two solutions. We've got our turning point and we've got our y-intercept. All we need to do now is draw that sketch. And again, it is just a sketch, so let's just draw it as best we can. Let's have a look, it's going through -2 and 8, so it's coming sort of over here. And let's label all those points on. So -2, 8, we've got the y-intercept just there at 16, given to us in the question. And then we have this turning point just here, and that turning point is 3, 25, and there we go. Obviously, when you're doing this sketch, you do need to be a little bit more aware of where that turning point is, because it's going to dictate sort of how far to the left or to the right you're going to draw that curve. Obviously, looking at my sketch there, my y-intercept 16 is very close to my turning point of 25 as that y-coordinate, but as long as you try and draw it as best as you can, you don't need to stress too much about it being absolutely perfect. Obviously, the more accurate you draw it, the better, but it is just a sketch where we're labelling the points on. Really what we're showing is we've identified the fact it goes through a negative and a positive on the x-axis. We've identified that we can find the y-intercept, and we've identified that we know that shape of the curve, that it's going upside down, making that N shape. Okay, so there we go. Right, I've got one question for you to have a go at, then we're going to have a look at a little extension question to finish. Okay, so here's your question, putting everything together, completing the square, solving and drawing that sketch. So pause the video there, have a go at this question, I'll go over the answer in a sec. Okay, so I'm going to start by completing the square. So let's take that -1 out, and that would give us positive x squared minus 6x minus 40. And completing the square from there, we're going to get x minus 3 in brackets squared. That would give us 9. We want to get back to minus 40, so I'm going to have to take away 49 from that. That'll get me back to minus 40. Bring that negative 1 back in. And to be fair, you could actually just do that without writing this last bit of working out. But there we go, minus 1 lots of x minus 3 squared plus the 49. So the coordinates of our turning point are going to be positive 3 and then 49, quite similar to our last one. And then let's solve it. So we'll take this bracket here and we'll solve it from there. So for our factors, we can have 1 and 40, it's not that. We could have 2 and 20, it's not that. 4 and 10, yeah, that's going to work. There we go, so 4 and 10, we want to make negative 6. So that'll be x plus 4 and x minus 10, and we'll set that equal to 0 here for solving. Okay, so finishing that off, we'll swap the symbols over on the second bracket. So x plus 4 and 10 minus x. And there we go. And we're getting our solutions from that. So for our first one, we've got x is minus 4, and for the second one, we've got x is positive 10. And not forgetting our y-intercept, which was given to us in the question. Okay, so let's draw our sketch. So drawing an axis. It's going to go through minus 4 and 10. Let's bring that all the way over there. Let's just extend that slightly. And let's label all these pieces on. So there we go. That was 40 on the y-intercept. We have negative 4 over here. We've got 10 here. And for our turning point, which we can label on, I'll just put the coordinate in here. We've got 3 and 49. And there we go, there's the sketch of our quadratic. Right, well done if you've made it this far. There's quite a lot of maths going on there. These negative quadratics have thrown people quite a few times, but we're going to have a look at one little extension question to finish off, so let's see if you can do that. Okay, here we go, so here's our last question. Now, just a very quick discussion of this before you maybe try and have a go, but you will notice that the coefficient of x for 1 is an odd number, so when completing the square that's going to form a decimal, although you can use a calculator for this question, but there is going to be decimals involved. And a little hint for you, this one doesn't factorise, and when a quadratic doesn't factorise, you need to use the quadratic formula. So this is a calculator question, the rest of those could have been non-calculator, but this one here is explicitly calculator. So a couple of little hints there, but I would encourage you to have a go. This is our last little question, so if you pause the video and have a go, otherwise let's have a go at going through this one. So, if I go about completing the square to start with, it wants us to draw a sketch showing the coordinates of the turning point and any intersections with the axes. So let's take out that factor of minus 1. So when we do that, we get x squared plus 3x minus 5. Now if we complete the square for this, it's not too difficult, particularly as we have a calculator, but we get x plus 1.5, or you could leave it as a fraction 3/2 squared. Now when you expand that bracket, 1.5 squared is 2.25, and we need to get back to negative 5. So you can do that on the calculator if you need to, but we're going from 2.25 down to 0, and then an extra 5. So we're going to have to take away 7.25 to get down to minus 5. Now we need to multiply that minus 1 back in, just like we have done before. So put that minus 1 back on the outside, and we get minus 1 lots of the x plus 1.5 squared minus 7.25, and obviously when we times that minus 1 in, it becomes plus 7.25. So there we go, we've got the coordinates of the turning point, not too bad there hopefully. Minus 1.5, the opposite in the bracket, and then 7.25 for our y coordinate. And again, we can solve it from here, and if we go about doing that, let's see what we're going to get. Now, we could solve it from there, but we should really just solve it from the original quadratic. Once we've identified the fact that it doesn't factorise, we may as well just use the original quadratic, because it's not really going to matter which one we use there. So if we bring the original quadratic down, and we solve from there, we've got our values of a, b and c that we're going to have to put into the quadratic formula. So a is the number in front of x squared, which is minus 1. b is the number in front of x, which is minus 3. And c is the number at the end, or at the start in this case, which is the 5. And if we plug all that into the quadratic formula, so obviously you need to know the quadratic formula for this as well, so I'll put that in the description. Don't worry, everything that's gone on in this will be linked in the description for you to have a go at. I'll try and put them in order for you as well for how they've occurred in the video. But if we put those into the quadratic formula, let's have a look. So we have minus b at the start, so that's positive 3 now when we flip that, plus and minus the square root of b squared, so negative 3 in brackets squared, take away 4 times negative 1 times 5, and that's all over 2a, or minus 2. Two lots of minus 1. Now if we type that into the calculator, obviously using the fraction button there, and just being careful how you sub all these numbers in, using the negative button for your negative 1, putting your negative number in bracket there for the b squared. For the version with the plus sign, we get, and I'm going to round these to 2 decimal places for this one. It doesn't actually say 2 in this question, but for the purpose of our sketch, we're not going to want to write all these decimals. It comes out as minus 4.19 to 2 decimal places. And if I go back into my calculator, change that plus for a takeaway, our version with the takeaway comes out as, and again to 2 decimal places, 1.19. So there we go. Obviously in a question like this we would just leave it as a full decimal if it didn't say how to round it, but for the purpose of this little bit of practice we're not going to worry too much about that. So obviously we've got a negative and a positive solution again. So if we draw our quadratic, again we're just going to do a little sketch. And it's going to go, let's have a look, minus 4 over to 1. I'm trying to make it as accurate as I can, or not over-egging the whereabouts it is on the graph too much. But there we go, we've got minus 4.19. Over here we've got positive 1.19. We've got a y-intercept, which again we can get from our original equation of 5. And we have our turning point, which is just here. Not the best drawing there by me, but minus 1.5, 7.25, just about get that on there. Okay, obviously just emphasising the fact that that turning point is to the left of the y-axis, as we have a negative 1.5 as the x-coordinate. So there we go, really tiny little sketch there at the bottom, but just showing you how this could obviously get a little bit harder, obviously with completing a square with an odd number as the coefficient of x, but if you have a calculator that's nice and easy enough, and then obviously using the quadratic formula as well. So it was a pretty tough question to finish on, but there you go, you can see obviously with what the extent of these questions and how difficult they could potentially be, and I hope that was useful and helpful. But that is the end there. So if you found that useful, please like, please comment, please subscribe, and I'll see you for the next one.